What's going on, guys? My name is Matt and I am back with a new PC build. This time the price point is $800, and for that price you're getting a seriously powerful system. This video is going to be a full build guide, meaning I'm not only going to be showing you each of the parts and why I picked them, but I'm also going to be showing you how to put everything together step by step, and then finally I'm going to be showing you both gaming and streaming benchmarks. Because believe it or not, this $800 PC is pretty darn good at streaming. While there are obviously tons of different ways you could have spent this budget, I went with parts I know are quality, that'll work well together, and will last you a long time. So let's start things off by talking about each of the parts that make up this budget gaming beast. So the first thing I usually select with this system is the CPU. This determines a number of other factors for the build, and other than the GPU, this has the biggest impact on gaming performance. There are a number of different options to choose from, but after careful consideration, I decided to go with the AMD Ryzen 5 7600, which comes in at around $190. The 7600 has 6 cores and 12 threads, making it perfect for not only AAA gaming, but also plenty powerful for streaming and light workstation applications. This is truly a jack-of-all-trades CPU. It can turbo all the way up to 5.1 GHz, and one other nice thing about it is the fact it has built-in graphics. We won't be needing them as we are going with a dedicated graphics card, but having the iGPU as a backup is great for troubleshooting or for temporary use while your graphics card is out of your system for whatever reason, be it RMA or upgrade. Our Ryzen 5 CPU will be slotting into the ASRock B650M PG Lightning. This is a $120 motherboard with a ton of features, including 4 DIMM slots, 3 M.2 slots, front panel USB-C, and VRMs that are capable of supporting up to a Ryzen 9 CPU. The back panel I/O is also nice with plenty of USB ports, 2.5 gigabit LAN, a BIOS flashback button, and even built-in Wi-Fi, which I know is important to a lot of you. The color scheme is also nice and neutral, meaning it'll fit aesthetically into most builds. Overall, I'm very impressed with this board, and in my opinion, this is the best budget AM5 motherboard available for purchase right now. Moving on to the cooler, in a build like this, I would normally go with the stock cooler as our CPU does actually include one in the box. With that being said, the Ryzen 5 7600 runs a fair bit hotter than previous entry-level Ryzen 5 chips, so I decided to spend a little bit extra and get an aftermarket cooler. What I went with is the Thermalright Assassin X120. This is a $17 tower cooler that offers 4 copper heat pipes, a good size aluminum fin array, and a 120mm fan. This cooler will allow our R5 CPU to stay cool and quiet while even under the most intense load. In terms of RAM, I was on the fence of whether or not to go for 16 or 32GB, but after some deliberation, I decided to go with this 32GB kit of Team Group T-Create DDR5 memory clocked at 5600 MHz. With a price tag of around $80, this is a great value per dollar kit. 32GB is more than enough for gaming, streaming, and even light video editing. This is also a 2-stick kit, meaning it'll be running in dual channel operation, which is optimal for max performance. For storage, this is an area where we do have to compromise a bit to fit within our budget. What I ended up going with is this 500GB MSI Spatium M450 NVMe SSD. This is a solid budget drive coming in around $40 and offering PCIe 4.0 connectivity. 500GB should be enough for your OS, applications, and a few of your most played games. With that being said, if you can stretch another $20, then you can get a 1TB drive, which will be linked in the description down below, along with all the other parts mentioned in this video. Another nice thing about this SSD is the fact it comes in the ultra-compact M.2 form factor, meaning installation takes literally seconds and there are no wires to mess with. Moving on to the graphics card, after looking at the available options, the card that made the most sense to go with, and the one that fit best in the budget, is the AMD Radeon RX 7600, which is a great pairing with our Ryzen 5 7600. Coming in at around $250, the RX 760 8GB offers great 1080p gaming performance and even decent 1440p performance in a lot of games. The specific model I went with is the XFX Speedster model that features an all-black dual-fan design with a metal backplate and nickel-plated copper heat pipes. If you absolutely need an Nvidia card, you could go with the RTX 4060, but that card will be $40 to $50 more and perform very similarly. All in all, I think the RX 7600 is a great fit in this build, and if you're interested in performance and temps, make sure to stick around to the benchmark section of the video. This system is pretty power efficient with an estimated 270 watts of power usage under full load. With that being said, I knew I wanted to get a power supply with a decent amount of headroom for future upgrades. Because of this, the best unit that fit into our budget was the EVGA 500BV. This is a 500 watt, 80 plus bronze rated unit coming in at around $45. This 500BV will offer plenty of clean and reliable power to the entire system and even looks pretty nice with all black sleeve cables. This is a non-modular unit, but luckily the excess cables are pretty easily hidden away in our case. Speaking of which, the case I went with is probably the best budget case that I've ever worked with. At under $60, the Okeanos Aqua 3 offers the fish tank style design that's all the rage right now. 3 included RGB fans with a button to control them on the case, plenty of dust filters, and front panel USB-C, which I don't think I've ever seen on a case this cheap. It also uses a pretty neat airflow design by pulling in air through the bottom mesh and exhausting it through the top, which again, if you're interested in temps, I will be showing and discussing them after the benchmark section of the video. All in all, for $800, you're getting a set of quality parts that'll last you a long time and allow you to do a ton of different stuff on your PC, from gaming to streaming to even video editing. So now that you've seen each of the parts and understand why I picked them, I'm now going to show you how to put everything together step by step. There are a number of ways and orders to assemble this system, but I'll go over my preferred method. Before you get building, it's important to make sure you're ready by gathering the right tools and have an open area to work on. The only tools you'll need is a standard Phillips head screwdriver, a smaller Phillips head screwdriver for the M.2 screw, and something to tighten standoffs like a pair of pliers or preferably a nut driver. I personally use a multi-bit iFixit kit for both the small Phillips head and nut driver. With that being said, there are much cheaper multi-bit kits, and I'll link the main screwdriver I use along with a few different multi-bit kits in the description below. With your workspace ready to go, your schedule clear, and your tools in hand, it's now time to start building your PC. So the first thing you're going to want to get out is your motherboard box. Go ahead and open it up, take out the I/O shield that looks like this, an M.2 screw that looks like this, the Wi-Fi antenna cables, this plastic clip, and the Wi-Fi antennas if you plan on using Wi-Fi, and the wrapped up motherboard itself. Pull the motherboard out of the bag, set it to the side, put the bag back in the box, and then put the motherboard on top of the box. Now you can open up your CPU box, grab the CPU clamshell from it, and bring your attention to the CPU socket at the center of the motherboard. Start by pressing down and out on this metal retention arm, then lift it up so it's fully open like this. Then lift up on the socket in the opposite direction like this to expose the pins. Now take your CPU, handling it only by the edges, and line the marked corner on it with the marked corner on the motherboard. Once lined up, lower it into place, applying no pressure. Sorry for blocking the camera, and it should just slot in. Now lower down the socket cover and lower down and re-secure the retention arm like this. You can now lift away the plastic socket cover and make sure to keep this. You can just store it in the motherboard box as you may need it in the future. Next, remove these 4 screws surrounding the CPU socket and lift away the 2 plastic pieces like this. Next, shift your attention to the CPU cooler box, open it up and pull out the fan, the hardware bag, and the cooler itself. Out of the hardware bag, we'll need the tube of thermal paste, these 2 metal brackets, the 2 fan clips, and the AM4/AM5 section of the screws and spacers. Now place one of the spacers on each of the mounting pegs surrounding the CPU socket. Next, secure the 2 metal brackets using the screws that came in the bag with the spacers, making sure they're tightened all the way down. With that done, take the tube of thermal paste and apply a pea-sized amount to the center of the CPU IHS. Now grab your cooler, making sure to remove the sticker at the bottom and lower it down onto the motherboard like this. Next, screw down the cooler a few turns at a time, going back and forth to ensure there's even mounting pressure on the CPU. I like to tighten these all the way down and then loosen them half a turn each. Now grab the fan that came with the cooler and attach the 2 fan clips like this, making sure to be aware of the fan cable orientation. Bring the fan over with the cable facing the top of the board and press it against the heatsink. Now pull the first clip over the heatsink like this, then do the same thing for the second clip, making sure the fan is nice and secure. Next, bring your attention to the CPU fan header located at the top of the board next to the RAM slots. Take the fan cable from the CPU cooler and line the notch in it with the bump out on the fan header and simply press it into place like this. With that done, you can now optionally tuck the fan cable away to neaten up the looks. The cooler has now been successfully installed and we can now move on to our RAM. Get out your RAM sticks and find slots 2 and 4 on the motherboard counting from the cooler. Open up the clips on both ends of these slots. Bring your first stick of RAM to the slot and line the notch in it with the notch in the slot. Once lined up, go ahead and lower it down, then press firmly on both sides until the stick is secured in place and the clip snaps shut. Then all you have to do is repeat that same process for the second stick of RAM and your memory will be successfully installed. Now go ahead and grab out your M.2 SSD along with the M.2 screw we pulled out of the motherboard box earlier and bring your attention to the top M.2 slot on the motherboard labeled Blazing M.2. Take your SSD oriented like this and line the notch in it with the notch in the slot and go ahead and insert it at an angle like this. You can now hinge it down and secure it with the M.2 screw like this. With that done, we now need to prepare the M.2 Wi-Fi. Start by removing the M.2 Wi-Fi card in the opposite way we installed the M.2 SSD and reinstall the screw in the board for safekeeping. We're removing it because it's much easier to work with outside of the board. Now get out the Wi-Fi cable / mounting hardware and the plastic cover. Now with the Wi-Fi card on a desk mat or soft surface like cardboard, take the small end of one of the Wi-Fi cables and press it into the Wi-Fi card like this. Now take the second cable and press it into the other spot on the card. This is a little annoying to do, but it's much easier than trying to do it with the card still in the board. Now take the plastic cover and press it onto the card like this. Now grab out the I/O shield for the motherboard as we're going to be putting the cable ends through these two holes above the BIOS flashback cutout. Take each cable and press them through the two holes in the I/O shield like this, then place one washer over each of the two antenna ports and hand tighten a nut over each of them. With that done, you can place the I/O shield and motherboard off to the side and get out your case box. Open it up and get the case out. One tip for this is to pull the box away from the case instead of trying to pull the case out of the box. Once out and on its feet, remove the two thumb screws holding the glass side panel, then pull back on, hinge out, and lift away the glass panel. Next, hinge forward the front glass panel to release it, then lift it away. Finally, remove the two thumb screws securing the back panel into place, pull back on it, and lift it away. At the back of the case, undo this bundle of cables like this and pull out the white box, which inside contains all the screws necessary for assembling our PC. Now you can go ahead and lay the case onto its side so we can prepare it for the motherboard installation. Now get out two standoffs from the screw bag that look like this. We're going to be installing these into the two holes here and here in the case. I like to hand start these, then come back with a nut driver or pair of pliers to tighten them all the way down. With those two in, we need to also move this standoff to this hole beneath it. So just unscrew it, hand start it in the hole below, and then tighten it down all the way, and all of our standoffs are now successfully configured. Now take your I/O shield with the Wi-Fi card attached and orient it like this and bring it to the I/O cutout at the back of the case. Once lined up, press in each corner until the I/O shield is secured to the case. Once that's done, hang the Wi-Fi card over the side of the case like this to get it out of the way of the motherboard. Now take your motherboard, handling it by the cooler, and lower it into the case, lining up the I/O with the I/O shield and making sure you can see the standoffs beneath the motherboard holes. Then grab 7 motherboard screws that look like this from the screw bag and install one into each of the motherboard holes. You can go in any order you want, just make sure to tighten them down until they're snug and the motherboard is fully secure. With that done, you can now remove the screw for the M.2 Wi-Fi, insert the card into the slot at an angle like this, hinge it down, and then reinstall the screw to secure it into place. Once that's in, you can route the two antenna cables between the PCIe slot and the capacitor like this. Now you can go ahead and lift your PC back onto its feet and grab out your power supply. With the case cables out of the way, take your power supply with the fan facing down and insert it into the back of the case like this, lining up the holes in it with the holes in the case. Now grab 4 of the power supply screws that look like this and install one into each of the holes in the power supply, securing it to the case. With that done, it's now time to start routing cables. Start by taking the 8-pin CPU cable that looks like this and push it through this hole up at the top of the case here. Now take the big 24-pin cable that looks like this and push it through this hole here. Now take the PCIe power cable and push it through the hole here, which will come out in the main part of the case right here. Now take the front panel USB-C cable that looks like this and push it through the same hole the 24-pin connector went through. Next, take the USB 3 block connector and the tiny front panel connectors that look like this and push them through the same hole that the PCIe power cable went through, which again enters the main part of the case right here. Now take the HD audio block connector that looks like this and push it through this hole right here, which enters into the case right here. Finally, take the 3-pin fan connector at the end of this daisy chain and push it through the same hole of the HD audio connector went through. Now go ahead and grab the SATA power female connector coming off of the fan controller right here, along with a SATA power cable off of the power supply. Make sure they're oriented in the same way and then press them together like this. We can now set the case back onto its side and start plugging in the rest of the cables. Starting at the right side of the motherboard, grab the 24-pin connector and locate the 24-pin header on the motherboard. Make sure the two pieces of the connector are pressed together and line the clip on the connector with the bump out on the header. Once lined up, press it into place. With that in, grab the front panel USB-C cable and locate the USB-C header just below the 24-pin header. Orientation doesn't matter for this one, so just line it up and press it into place. Now bring your attention to the bottom right of the motherboard at the front panel header and grab the front panel connectors. Take the power LED connector and with the positive of the left, press them into these two pins here, again making sure the positive is to the left. Now take the power switch connector and plug it into the two pins directly to the right of the LED ones. Orientation doesn't matter for this one. Next, grab the USB 3 connector and find the header to the left of the front panel header. Line the notch in the header with the bump out in the connector and press it into place. Now to the left of that, take the 3-pin fan cable and press it into one of the two fan headers here, the same way we plugged in the CPU fan cable earlier. Now take the HD audio block connector with the text oriented like this and press it into the HD audio header right here. Finally, for the hardest one, take the 8-pin CPU power cable at the top of the case, press the two pieces together, line it up with the connector and press it into place. This is a pretty tight squeeze, so just be careful not to rub your hand against the CPU cooler heatsink as it is pretty sharp. Worst case scenario is you can remove the top fan, plug in the connector, then reinstall the fan. It's doable without doing that, but just know that is an option. With that done, it means the only thing left to install and plug in is the graphics card. Start by loosening this back cover, lifting it up, then tightening it back down. Now bend the top PCIe cover back and forth until it snaps off and can be lifted away. Then do the exact same thing for the cover just below that one. Now open up the top PCIe slot, grab out your graphics card, making sure to remove the plastic and PCIe connector cover. Now take your card and line up the notch in the card with the notch in the PCIe slot. Now lower the card into the slot, and once lowered down, press it into place until the PCIe lock snaps shut and the card is secure. Next, loosen up, hold down on, and resecure the panel we lifted up earlier, and then secure the GPU bracket into place with two of the same types of screws we use for the power supply. With that done, take your PCIe power cable, press the two pieces together, line it up with the header on the card, and press it into place. Now put the case back onto its feet because there is one more thing to do before reinstalling the panels and boot it up for the first time, which is cable management. Note this is a good time to also test boot it if you want to make sure it does post. For cable management, just pull all the excess cabling to the back of the case and use zip ties to secure cables to the back, and you can tuck any excess cables into the power supply basement like this. One recommendation is to zip tie the PCIe power cable together like this to make sure it looks a little bit cleaner. Once everything is relatively neat, go ahead and put the back panel back on, resecuring it with two thumb screws. Then you can insert, hinge up, and press in the front glass panel, and finally you can take the side glass panel, remove the interior protective plastic, insert it at an angle, hinge it up, and then slide it forward. Then secure it with the final 2 thumb screws. With that done, you can take the 2 front plastic peels off and are ready to boot the system up for the first time. But before you can start downloading and join games, you'll need to install Windows and the drivers. I'm not going to go over how to do that in this video, but I'll leave links to both a guide on how to install Windows and links to all the necessary drivers in the description below. Once the PC is up and running in Windows, we need to also enable the RAM's XMP profile in the BIOS. With the PC off, turn it on and immediately start pressing the delete key. This will bring you into the BIOS. At the top right of the screen, press the button that says Easy Mode. Now at the center left of the screen, press the profile button under DRAM info to change it from Auto to Expo. With that done, press F10, then hit Yes to save and exit back into Windows. With that done, you're now ready to start downloading and enjoying your games. Speaking of games, I think it's now time to talk about gaming performance along with streaming performance. I tried to test a wide variety of popular titles, but if there's one you think I missed or would like to see tested in the future, let me know in the comments down below. So without further ado, here are the gaming benchmarks. So let's go ahead and start out with the game that never seems to die, which is Fortnite. I test this game 2 ways, both at 1080p, both in DX12 mode, and both in Team Rumble's matches. First, I tested using the high preset with 100% 3D resolution. Doing this resulted in a really nice looking game and pretty solid performance with a 67 FPS average and 1% lows of 54, which if I was playing this game casually, this is probably the settings I would use. With that being said, I also tested at competitive settings, which entails epic view distance, high textures, and pretty much everything else set to low. Doing this resulted in a much higher 118 FPS average with 1% lows of 85. This was very solid performance and should be enough for competitive play, but you do have the option to play around with the settings a bit more to try and squeeze out even more FPS. Moving on to Helldivers 2, I test this game at 1080p using the high preset and native resolution. I just hopped into a random mission and ran around shooting stuff. Doing this resulted in a smooth 85 FPS average with 1% lows of 75. This looked and felt really nice, although I do think I have the game brightness turned up way too high, as you may be able to see whenever I ADS and the flashlight turns on. With that being said, I don't really know what FPS people consider good or acceptable, so let me know what you think of this performance in the comments below. Next up is the esports title Valorant, which I tested at 1080p high settings and by hopping into a few death matches. To no one's surprise, the FPS was super high with a 483 FPS average and 1% lows of 232. This was obviously super smooth and enjoyable, but no matter how high my FPS is, I still absolutely suck at this game. For the next game, I tested Borderlands 3, which is a slightly older AAA title. I tested this game at 1080p using the Ultra preset and the built-in benchmark. Doing this resulted in a solid 115 FPS average with 1% lows of 95. This was very good performance in my opinion and shows that this machine absolutely crushes older AAA titles at 1080p Ultra settings. Moving on to Cyberpunk 2077, this game was a bit surprising performance-wise. I tested this using the high preset, leaving everything as is and using the built-in benchmark. Doing this resulted in a 119 FPS average with 1% lows of 87. This was pretty solid in my opinion and was pretty indicative of the performance that I saw in-game when just driving and messing around. Next is another esports title in the form of Rainbow Six. I tested this game using the built-in benchmark at 1080p Ultra settings. Doing this resulted in an impressive 370 FPS average with 1% lows of 275. This again is very good performance and shows this PC is a bit overkill for games like Rainbow Six. Finally, I tested Rust, which I still have no idea what to put the settings to, so I just tested at 1080p with what it defaulted me to, which is on screen right now. I then just hopped into a random official server and ran around along a road. Doing this resulted in a 99 FPS average with 1% lows of 45, which seemed pretty smooth, but do note I didn't go by any major structures or get into any gunfights or anything. If you guys have recommendations for the settings I should test in future videos for Rust, then let me know in the comments below. All in all, gaming performance on this $800 PC is super solid in any game at 1080p. With that being said, how does it perform in streaming to a site like Twitch? Well, I downloaded OBS and let it do its auto run thing and ended up with this output. I decided to test streaming a AAA title in the form of Cyberpunk and an esports title in the form of Valorant. Starting with Valorant, the stream and gameplay was smooth on both ends and there was basically no performance hit while streaming from what I could tell. Moving on to Cyberpunk, this was streaming at the same 1080p high settings that was tested on, and I was happy to see the FPS average well above 100 through the entire test. This was great to see and shows that this PC will be able to stream pretty much any game you want to Twitch at 1080p. In terms of temps and noise, temps were great with neither the CPU or GPU going above the upper 70s. In terms of noise, this PC is definitely audible but not obnoxiously loud while gaming, and the only minorly annoying thing noise-wise is the GPU coil whine when the FPS is super high, like 700 plus, which only really happens in menus with uncapped frame rates. So yeah, all in all, this $800 gaming PC is an absolute beast in terms of gaming and streaming performance. There are obviously a ton of ways you could have went with this build, so if you would have picked different parts, let me know what you would have went with in the comments below. So yeah guys, I think this wraps this video up. These build guides are a lot of work, but if you keep watching them, I'll keep making them. If you enjoyed this video, consider giving it a thumbs up and subscribing, and as always, this is Matt from Tech by Matt, signing out.